Welcome everyone, my name is Vishwa Mohan, and in this video we are going to see that if I today want to become a rock solid Java developer, if I want to make it big in the space of technology using the Java stack, what are the things that I need to learn and in what order. So I'm going to discuss the entire roadmap that how in year 2023 and going ahead, if I want to make it big in IT as Java as the tech stack, what are the things that I need to learn. So let's get started. So before we jump into and talk about the entire roadmap, what are the things that you need to learn, first of all, let's try to address the elephant in the room itself. The very first question, that what is Java? So simple explanation of that is that Java is a programming language. I'll assume here that we don't know anything. So the next obvious question that comes to your mind is then what is programming language? So programming language is a mean through which you can go and interact to the computers. See, even in our humans world, let's say that for example, if I am from India, let's say that I only know how to speak Hindi. Let's assume that. And there's another guy and let's say that this person is from Japan. So this person only knows how to speak in Japanese. Do you think that there could be any conversation that can happen between these two persons? Do you think that any kind of, interaction can happen these two persons? It's not possible, because if I'm talking Hindi, that person who understands only Japanese, they doesn't get anything, any context out of the conversation. So how can I make sure that what I speak, that person understand, and whatever that person is trying to converse, I am able to understand it. So for that, we have to find a common ground which both of us understand. So one common solution to that could be that I make use of a language which both of us understand. So what could be that? I'll make use of, let's say that English. English being a common language, a global language. Now, if I start conversing in English, there's a chance that this guy can understand that, and then he can reciprocate and we can communicate and get the work done. Same thing applies in the world of computers. Here, when we are talking about the human, who are the smartest species on the earth, they still need something common to converse. When I talk about computers, computers are the dumbest creature. They only understand the language of 0 and 1. We as a human understand something, for example, called as English. So I need some common protocol. I need some common language which, if I give directions to the computer is able to understand that. And those instructions that we give in a logical fashion to the computer, so that we make sure that computer is doing the work we want them to do, is called as the programming language. The programming language is the language which the computer understands. So we understood that Java is a programming language. But what kind of programming language? We saw that it is a programming language. But what kind of programming language it is? So the kind of programming language Java falls into, we go and call it as an object-oriented programming language. Now this is a new term. You might be frowning upon that. What is this new term now? Object-oriented programming language. Let's try to understand this. So if you look around the year 2000s, there is one thing which took the entire world with a storm. Can you guys put that into the comment? Pause this video and tell me what happened in year around 2000 which took the entire world for a toss. People start thinking in a totally different way. That new change was WWW revolution. Right? Or I can say that internet revolution. What it brought to the table is that almost anything and everything was brought to the world of programming. If I go and talk today in today's modern world, right? If I look around myself since morning till night, everything that I need, I have a programmatic solution, an application running on my mobile phone that does that work for me. Say for example, if I have to buy stuff, I can go and order on Amazon. If I have to go and get veggies, I have big basket. If I'm feeling bored, I want to connect with my friends, I have Facebook, I have Instagram. Even today the dating kind is sorted. So if I want to date someone, I don't have to go out, take risk. I can just do left, right, swipe, all thanks to Tinder. If dating app is not helping me much, I can go for the matrimonial site called shaadi.com. If I'm tensed after doing Shaadi, I can use something called doctor.com. The point that I want to make here is that today, if you look around yourself, for every real world problem, you have a practical, programmatic solution in the world of internet. What it means that almost every company, if I go and look around every company, they are trying to solve the real world problem. And what is the real world problem? When you try to solve real world problems, in the real world lies entities, a living being like you and me. Or it will have someone like a non-living entity like a car. So if I'm trying to solve the problem of this real world, I have to go and represent that in the world of programming. That's the first problem. If I have to solve the problem in the real world, these real world entities have to be represented in the world of programming. And for that, all the previous programming styles, they were not sufficient. And in order to solve this problem, a new programming paradigm brought into the picture. And that was called as object-oriented programming. And at the center of the object-oriented programming was something called as objects. So object said that, hey, you know what? I will try to represent this real world entities. I will represent their state. I will represent their behavior. Okay, so this was just one part of the problem. Solving the real world does not only require that you represent the real world entities, but there was another complicated thing, and that was relationships. Now, if I have to solve the real world problem, I have to represent relationships also in the world of programming. How do I do that now? And for that, object-oriented programming said that, wait, I have a solution for that also. And for that came object-oriented principles. So making use of object-oriented programming and its principles, I can assure you that you can solve every problem which is related to this real world. And that's why in today's modern world, if you want to become a software engineer, there's a very high chance you're trying to solve the real world problem. And if you're trying to solve a real world problem, you should learn a programming language which is object-oriented programming. Unfortunately, Java belongs to that category. So Java is a object-oriented programming language. So I believe by now we are all clear that what is Java? Java is a programming language which belongs to a category called as object-oriented programming, and that's why it can be used to solve the problems of the real world. Now let's try to move on and see the history of Java. If you see, the Java got started somewhere around 1996, and if I talk about 2023, it's already Java version 21 has come up. Now with this change, if you see around almost every year, Java has been trying to upgrade itself, improve itself. This is one of the most important things that I love about Java. If I talk about IT sector, you will find that in the IT sector, one of the most unique and the most challenging thing about the IT sector is the change is the only constant. If I go and talk about the almost 70 to 80% of the world is still moving around Java 11 only, and I think most of them are still on the Java 8. But I go and talk about Java still has already released the features around Java 21. What do we understand from this? Java is always at the forefront. It is always futuristic. It is always understand that if I have to stay relevant in the market, I have to keep improving ourselves. I'll give you a few examples. One of the beautiful things about Java. Few years back, when Java was doing good, people started a new buzzword in the market. They started talking about the functional programming. Now, I'll not talk very deep around what a functional programming is, but in a very simple words, it's a programming language where functions are the first class citizens. Everything revolves around the functions, and its purpose is to provide scalable systems. right? Concurrent systems. So the proponents of the functional programming, they say that if you make use of functional programming, you'll be able to make systems which is highly performant, highly concurrent. And on this backdrop, a new programming language was coming into the play, which was called as Scala. Scala was saying that, I got great things, I'm functional, and you can help me, you can make your use of me to make the scalable application. At the same time, Java was just observing it. Before even the Scala can put its foot right, Java released with one of the greatest releases of all time, Java version 8. In that, it added the features of functional interface, Lambda, and many more. And before even the Scala can put its foot strong in the market, Java ensured that it has all the features which is needed of functional programming as well. The point that I want to bring it here is that Java is very aware. It is aware that what is going along in the market, and it makes sure that it tries to keep itself updated and always looking futuristic in the market. So this is how the Java version has evolved over a period of time. It started from 1996 and still going strong. And I don't see a reason why Java is going to go for a stopper in any coming few years. Great. Now let's try to move on. Talking about why should I learn Java? I think already 2 points I've already mentioned. If I go and talk about why should I learn Java, first of all, it is object-oriented programming language. So it will help you build the real-world application which almost every company is trying to make. That's number one. Number two, I said that it's always evolving. It's always changing and evolving. And the third thing is that this Java, you can build almost everything. If you try to look around yourself and see what are the different kind of applications, what are different kind of use cases where Java could be used to build products for us, you'll find almost anything and everything could be built using Java ecosystem. So whether you're trying to build a web application, whether you're trying to build an IoT devices, whether you're trying to build the mobile apps, whether you want to build the chatbots, you want to make games, you want to make the enterprise application, you want to make the scientific applications, almost anywhere you want to build anything, trust me, if you choose Java, you cannot go wrong. So Java is such a versatile language and the tech ecosystem that it has behind it that today you want to build anything and you can have Java at your back. Said that, moving on, I'll try to keep this whole roadmap of the Java related to a specific topic. Since most of the companies today are working for making web applications, so I'll try to restrict the roadmap or the learnings that you need to have, that how Java, as a Java developer, you can be a good web application developer and where it contributes. So if I go and talk about in today's world, any web application, if I go and talk about any web application, it comprises of three parts. The front end, which normally your end user uses, say for example, when you type www.facebook.com in the browser and whatever that turns up there, is something which is built by front-end engineers. Mostly JavaScript, HTML, CSS is what it is built of. But have you ever thought of that this front-end, typically when you open Facebook, when you open LinkedIn, when you open Instagram, how is this front-end being powered with so much of data? From where is this huge amount of data coming in? Who is providing this data? Where the entire logic is written? Who is doing the crunching and munching of the data? That typical layer is called as backend. This is called as backend. In the world of web applications, typically this layer where you write all the complex logic, where you do the very tough, very hard, complicated computations, you do the crunching and munching of data and make sure that front end has all that data available, that's built in Java stack. So you can make use of Java stack to build this scalable backend. Said that, it looks very simple right now. But in order to build this backend application, there are many things that we need to learn and master to become a solid backend developer in the modern world. And to tell you, in the today's market, if you become a good backend engineers, people, the average salary, the average starting salary of a very good backend developer in the international market is close to around $150K, which is more than a crore in the Indian currency. So that's how hugely demanded a well-skilled Java developer is. So now let's try to understand that if I want to become a solid backend developer in Java today, what are things that I need to learn? So we'll try to take up baby steps. We'll try to tell you in each step how things has to be done. So the very first thing that I need to do today is that I have to first of all understand the programming, the fundamentals of programming. So I have to understand that in Java, how can I do all the basic stuff? So I should know how to install it. I should know how to run the program, the concepts around the variables. I should know how to write functions. I should know how to write loops. I should know how to write the conditionals. I should know all things about the exception handling, right? I should know about the IO. I should know about the classes and objects. So the first thing that I need to do is that I have to make sure that I understand the basic nuances, the core concepts of the Java. This is the first thing that you should try, learning the art of making the Java application. So the very first thing, make sure that you are learning Java. On this YouTube channel itself, we'll try to follow this strategy where we bring to you this Java programming language where you get to learn in the best way possible to master this whole art of Java programming. Now let's try to move on. Once you have done that, then there are a few advanced topics in Java. For example, you can talk about threads. You can talk about the collection framework. We can talk about, say, for example, reflection APIs, newly added features. Trust me, Java is so advanced that getting to know almost everything in Java is next to impossible. But what we need to make sure is that we have to understand some basic construct, and as and when we need to build application, we have to go and reference to the documentations and keep on evolving, because Java is improving and getting better, evolving at a very fast rate. So far what we have done, we have tried to understand the basics or core Java, and then we have jumped to the advanced Java depending on the use case or the application that we are trying to solve. Once that is done, you have understood this. The next thing around is that, I know that if you're learning Java, you're learning Java to ultimately build applications, right? You're learning Java to ultimately build applications. And if I talk about application, any type of application that you would like to go and build, a small application, a big application, a super big application, at the end of a day, every application needs to store some form of data, store some form of information about their customers. And where do we store that data? We need to store this data in the databases. So when you're writing this application is written in, say, for example, Java itself, right? Java is being used to write this application. There should be a way that I should be able to interact my application with the database. I should be able to make use of the programming language and talk to the database. The second thing that I need to learn is that JDBC connection, how Java programming language could be used to connect to the database like MySQL, Oracle, MongoDB, all those things you should be aware of, so that when you are writing the application, you don't feel the pain in connecting to the database for retrieving and manipulating a lot of data. Great. So we have understood that we need to do the database interactivity. Let's try to move on. Now you have learned the Java. You know how to write the code. You know how to connect to the database. This was good till the time you are trying to learn on your own, or you have been trying to build, the pet projects to learn something. But as soon as you go and start working in the industry, what happens in the industry? When you work on a project, on a single project, multiple people will be working. Now, when the multiple people are working on the same project, the different people will bring the different level of expertise in knowing and using Java. So there should be some framework or some ways through which we ensure that the minimum quality is maintained. We maintain the minimum quality. We also have to ensure that when these people are working, they are able to easily collaborate. And if there are a few common things which everybody has to write, there's no point of doing that redundant work, right? So we should make sure that few common things which is needed for everyone, it's already available, right? So no boilerplate code, no boilerplate code. So in order to achieve all these things, almost for every programming language, when you go and work in industries, you use something called as a framework. So framework basically helps you maintain the minimum standard It helps you easily collaborate, and it ensures that you don't have to write much of the boilerplate code. All the easy things, common things are already available out of box. So same way, when you are making use of Java, when you go and work in the industry, you'll have to learn few frameworks. Almost every company that works in Java today makes use of this framework called as Spring Framework. And a more evolved, lighter version of a Spring Framework is Spring Boot. So it becomes very imperative for every one of you who's learning Java to feel and get acquainted with these frameworks called as Spring and Spring Boot. Similarly, for connecting to the database, we have a ORM framework which is very famous again, which is Hibernate. So as a Java developer, it will be an extra advantage if you are comfortable with these frameworks. Going ahead, similarly, not only this, you also need to understand additional tools so that you are able to manage the entire software development lifecycle. You are able to manage the project, right? You are able to share it to the entire world. You are able to do the version controlling. You are able to do the deployment. So this Maven will help you typically in the project management, right? This Git will help you in the version control. And the Jenkins CI/CD pipeline will make sure that you have a regular deployments. So these are the additional tools which I believe as a Java developer you have to be handy, which will get you an extra edge and will make you aware that how typically end-to-end applications are developed and then deployed to the production in the industries. Now, once you have done this, you have kind of covered everything which will help you become a good Java developer. But said that, that's not enough. Today in the modern world, when I look around, everyone is trying to build the applications which is scalable. Everyone is trying to build the applications which follows the standard patterns, which are avoiding the mistakes which the people have already done, right? So even in the world of object-oriented programming, over a period of time, people have built application for mere years now. And based on their experiences, they have jotted down certain patterns. And when you make use of this pattern, it helps your applications becomes scalable. It helps your application get the less bugs. It helps your application look clean. Helps your application becomes, easily modifiable. So to become a 2x better software developer, to become a 2x better Java developer, it gets very imperative if you get understanding of these design patterns. There are several design patterns like solid design pattern, group of 4 design patterns, and these design patterns help you understand from the mistakes which people have done in the past, and you can make use of this pattern for building the modern applications. So I have a suggestion for every Java developer who is watching this. It's very, very important today in this modern world to have a very crisp understanding of the design patterns which will help you build this next generation application in a very scalable fashion. Not only that, you also have to understand few architectural patterns. We are living in a world where we are building applications in different forms. Say, for example, we are making use of monolithic. We have been talking about SOA, service-oriented architecture. Today, everyone is talking about microservices. Not only that, today is the age of cloud. Everyone is talking about AWS, Azure, Google Cloud. So as a software engineer, at the end of a day, the application that you're building, you have to fit inside one of these architectural patterns, say like monolithic or service-oriented architecture or microservices. And also you have to decide if you have to go and deploy your application on-prem or you have to take onto the cloud. So for that, even those understanding becomes very crucial. So understanding what microservices are, what are the microservices design patterns, what is cloud, how do I go and bring the application in the cloud also becomes very, very important. So in today's modern world, these are something which you cannot avoid even if you think yourself to be just a Java developer. So these are the things, if you do, you will set on the path of the success and you will be futuristic. So if I go and summarize the entire path for you, you have to get started with first of all the basics, where we go and talk about the core Java. And then using the Java, maybe you are able to write the codes, data structures and algorithms. Then you should go with the advanced form of a Java. And then you talk about the frameworks, tools, Maven, Jenkins, Git. And then finally the advanced, the system design concepts, the patterns, the architectural patterns, the cloud information. If you're able to do this, that's when you are in demand. So this was the entire roadmap. I'll make sure that in the same order where I talked about, I'll try to bring all the content for you people super free, entirely free on this platform in a sequential fashion. I'll try to bring the entire content on the Java as a programming language. You'll very soon see the content around the data structures and algorithm. We'll talk about the frameworks. We'll build the application. We'll see the cloud. So anything and everything which is needed to become a solid Java developer, I'll make sure that you're getting everything for free on this platform in sequential manner.